This video introduces learning, memory, and how the brain works, and how the structure of your thoughts influences your behavior. So let's first look at how the brain works. Your brain is made up of a number of different parts, but the active parts that we want to think about for this little section are the neurons. You have something like 100 billion neurons in your brain, and they look something like this image on the screen. Here we can see what look like to be about 3 different neurons, and the main one right in the sort of the center there with the brightest color is our neuron. Now, on the left-hand side here, that circular bit with the blue blob in the middle, that's the cell body. There's a nucleus inside the cell, and that's the cell body, and that's where most of the work happens. And hanging around the outside of the cell, these little fingery sort of tendrils or tentacles are called dendrites. And the dendrites grow out from the cell and connect to other cells. So each dendrite reaches out, and there could be hundreds, thousands, even up to 10,000 dendrites on each cell, connecting each neuron to other neurons. Coming out the other end of the cell body is the axon, and the axon is fundamentally, it's an electrical connector really. It's a tendril or tentacle that comes out, and electric signal comes down through the axon. And those little blobs that you can see hanging off the axon are called myelin. Now, not every axon will have myelin, and in fact, it's part of the learning function that the more you practice, the more you learn to do something, the more likely a myelin sheath will be formed over the cell, and it helps over the axon, and it helps the electrical signal travel down the axon. And at the far end of the neuron are the axon terminals. Now, the axon terminals connect via synapses to dendrites of the next cell, generally speaking. There's a couple of different ways neurons will connect, but generally speaking, the dendrites of one cell connect to the axons of the cell before it. So this is how a neuron in your brain works. And it's fundamentally a switch. It's an electric switch. So what happens is that an electric signal will come down the dendrites. So something happens, the dendrites are connected, remember the dendrites are connected to cells further up the chain, and to the axons of cells further up the chain. And what happens is that there's a little chemical reaction between the axon terminal of one neuron and the dendrite of another, and that creates an electric signal. So electric signals come down each of the dendrites. Some of those electric signals are excitatory, some of them are inhibitory. So some cause the neuron to want to switch on, and some of the electric signals cause the neuron to not want to switch on. Anyway, depending on the cumulative effect of all the electrical signals coming down from all the dendrites, the cell body, the nucleus of the cell, will either send an electric signal down the axon or it won't. So that's basically all that happens. Is electric signals come down from the dendrites, and depending on the combination of those signals, we either will or we won't get the neuron to fire. When the neuron fires, it sends an electric signal down the axon, which goes into the axon terminals and out into the dendrites of the next cell, and so on and so on and so on. The system just continues on. Now that's what's happening inside your head. Each neuron is just a switch. Depending on the signals coming in, it'll either switch or it won't, and if it does switch, it'll send an electrical signal down to the next cells or series of cells, or they won't, and it just goes on and on and on and on. The neurons are connected in this massive network. So you've got 100 billion neurons in your head, in your brain, And each neuron can have up to 10,000 synaptic connections. It can be up to 10,000 dendrites reaching out to axons of other cells. And it's the synaptic connections is actually what learning is. What learning is the creation or the removal of connections between the neurons. As you learn to do something, you establish connections between neurons, and if you forget to do something, or if you don't learn to do something, then those connections are not made. So, and these connections build up and build up and build up. Edward de Bono has a metaphor for this, which I think is quite interesting. He says, think of the brain this way. When you're young, the brain is fundamentally like flat ground, or here we've got sand. And so imagine this flat sand, and it's quite flat, and there's no marked grooves or signatures. It's hard to tell one bit of sand from the next. This is like the mind of a baby, of a young child. Thoughts are then like rain. So it starts to rain, and depending on how the rain falls and the angle of the rain and the undulations and the shape of the grids and the slight imperfections of the sand, the water will start to run and trickle downhill. And as the water runs and trickles, it starts to form little grooves in the sand. Now, the grooves were probably already there. We couldn't see them, but as the water is running, it starts to create these grooves, and the direction of the water is influenced by the underlying texture of the sand. This is how your genetics are impacting upon what you learn and how you think. But over time, as it continues to rain and continues to rain and continues to rain, over the days and weeks and months, those grooves will get deeper and deeper and deeper. And given months and years and centuries and eons, that water will create a groove so deep that it becomes a permanent feature. Now, what is carving, this is the Grand Canyon, what is carving that Grand Canyon is not the undulations in the sand, it's now the action of the water. The water now is the major force that is determining the path of that canyon. As you learn, your thoughts become so ingrained that they become the major influencer of who you are. So that's de Bono's little metaphor, which I think is really interesting to think about. Let's just sidetrack for a second. I want to talk about memory for a second. So just hold that thought. Hold that thought that we've got this water, or which are our thoughts, the surging through the sand, which is our brain, creating these rivers and estuaries and tributaries, which is our, the neural networks. Let's just sidetrack for a second. Let's talk about memory.